Hey guys, good evening. स्टार्ट करते हैं सर। ओह स्टार्ट करते हैं लेक्चर। गुड इवनिंग। ठीक है, तो we'll be solving some questions in this lecture. Okay, yeah. So if we are meeting for the first time, I would like to tell you that I've completed my MTech from IIT Bombay, ITB. I have 4 years of teaching experience, and I will be taking heat transfer, basic thermodynamics, fluid mechanics, and engineering mechanics on plus. Okay, this is our team who will be teaching you. Next, if you want to uh, get connected with me, you can connect with me on your, or I mean, you can contact me on my Facebook profile. You can search me by the name Viresh Kumar. My coupon code on Unacademy, if you are planning to buy Unacademy plus subscription, then my coupon code is Viresh10 for 10% instant discount. Okay. Unacademy, okay, my profile on Unacademy is by the name again Viresh Kumar. You can search me on Unacademy, and you can follow me for free special classes that I'm going to take from 19th June. If you want to follow me on Instagram, Viresh_05 is my username. Okay, so just basic information about me before we start this lecture. Good evening, guys. Good evening. Okay, so I'll not be going into the difficult numericals. I'll be teaching easy, and I'll be taking easy and medium level numericals in this class. So try to try to solve them, and then I'll be telling you the solution. Okay, first numerical on your computer screens. Come on, solve it. Solve this question. I am giving you 2 minutes. I'll be solving this question by two methods. Give me the answer. Hint. Should I give the hint? Use first law. Come on, solve the question. Use first law. क्या कह रहा है क्वेश्चन देखो. The question is saying that a 100-watt electric bulb was switched on in a 2.5 meter, 3 meter cross 3 meter size thermally insulated room having a temperature of 20 degrees Celsius. The room temperature at the end of 24 hours will be. Okay. First of all, you take the assume the density of air is equals to 1.24 kilogram per meter cube. This is a GATE previous year question 2000. It was asked in 2006. Use this density. Density of air is equal to 1.24 kilogram per meter cube, and also one data is missing, and that is you have to use CV or CV of air. Use it as 0.718 kilojoule per kilogram Kelvin. I hope the font is visible to you. You can comment in the this comment section. You can reply in the comment section. Solve the question. Give me the answer. See, I will tell you the importance of system, identifying the correct system and applying the correct system in this question. This question can be solved in two ways. Okay. Should I solve the question? Please reply, or you will be giving me the answer. Okay. See, uh, this is my room. Okay. And it is thermally insulated. It's given in the question that it is thermally insulated. Okay. So if I consider this whole room as my system, this is my system. Okay. And this is my bulb here. Okay. And it is it is doing electrical work on my system. Okay. If I consider the room as my system, what the room as my system, what it is doing electrical work on my system. Okay. And how can I find that? Work is equals to, see, this is 100-watt bulb and it is switched on for 24 hours. Okay. So 100 joule per second into 24 into 3600 seconds. The second and second gets cancelled out. I will get the work input to my system, the electrical work input to my system. Okay. The value will be, let me check the value. It is 8640 into 10 raised to the power 3 joules. Okay, that is 8640 kilojoule. This is the magnitude. Okay, this is the magnitude. What I'm saying is that the work is being done on the system. Okay, so when I will be applying the first law, in this case, Q is equal to delta U plus W. Correct? Let me move on to the next slide. Okay. So Q is equal to delta U plus W. Room is thermally insulated. This becomes 0. Okay. No heat interaction because I am considering room as my system. Okay. Delta U is what? mCV delta T. Correct? Plus minus of 8640 kilojoule. Take this here. This will be minus 8640. I mean, this will be now positive kilojoule into 10 to the power 3. That is joule is equal to, what is M now? You have been given the this volume of the room. Okay, you have been given the volume of the room and you have also been given the density of the air. So you can find the mass of the air in the room. Correct? How can you find that? Very simple. This is 2.5 into 3 into 3. This is volume into density, which is 1.2 kilogram per meter cube. This is the mass of the air in the room. Okay. CV is given as 0.718 kilojoule per kilogram Kelvin. But I have always said that try to solve the questions in SI units. Okay. So this is 0.718 10 to the power 3 joule per kilogram into delta T. Okay. So what was the initial temperature? It was 20 degrees Celsius. The final temperature, let the final temperature be T2 minus 20. To solve this, you will directly get T2 in degrees Celsius. It will be around, let me check the answer. It will be 451, I guess. 451. 451 degrees Celsius, approximately. Okay. Why negative, sir? See, I have considered this room as my system. See the boundary. I have considered this room as my system and the electrical work is being supplied to my room. Okay, that means the work is being done on the system. Okay, that is why I have taken the work input with a negative sign. That is our sign convention, right? Okay, if I now, this was case 1. when I have assumed room to be as my system. Okay. Okay. Now what I do is case 2. Now I will be considering air as my system. Air in the room as my system. Air in the room as my system. The answer will remain same, no doubt about that. But the concept that you will be applying now, that will be different. Now air in the room is the system. Okay. So whatever electrical work that was being supplied, the value was 8640 kilojoule, right? Correct. Now this, as I am considering air in the room, this air here as my system now, all the electrical work will be converted into heat and that will be supplied to the air. Okay. So now in this case, the air in the room is my system. Okay. So now Q will not be 0. Q is equal to delta U plus W. Now W will be 0 because all the electrical work by dissipation effect has been converted into heat and now my air is the system. Okay. So air is receiving the heat. Okay. Is it fine? So now Q is equal to 8640 into 10 to the power 3 is equal to M is 2.5 into 3 into 3 and into this density 1.24 CV is 0.718 into 10 to the power 3 joule per kilogram Kelvin. Try to solve the questions, try to solve the numericals in SI units. Okay. T2 minus 20 and you will again get T2 approximately equal to 451 degrees Celsius. Is it fine? Is it fine? Did you understand the concept? When I took the whole room as my system, I was supplying the work. The work was being done on my system. In the second case, what I did was I assumed air to be my system. Now all the electrical work that was coming into my room, now room is not the system, air is my system. That electrical work by the dissipation effect, it will be supplied as heat to the air. Okay. So in this case, I have written Q is equal to 8640 into 10 raised to the power 3 joule. Okay. And when the heat is supplied to the system, it is taken with a positive sign. Correct. Rohini, repeat second case, sir. When air is the system. When air is the system. When air is the system, that means this bulb is not in our system. Okay. I am considering the air in the room is my system, not this bulb. This bulb now is not a part of our system when I'm considering air as the system. Okay. So whatever the electrical work is being supplied to that bulb by the dissipation effect, that work will be converted into heat and that heat will be supplied to the air in the room now. Okay. So that is why I've taken this Q is equal to 8640 kilojoule. Is it fine? See the importance of system, and I've taken that Q with a positive sign because heat supplied to the system is positive. That is why I was emphasizing on understanding the concept of system properly in the first 2 lectures. Is it fine? Is it fine? The answer is C, I guess. The answer is C. Guys, the answer is C. Let's move on to the next question. This is the next question for you. Do it. Give me the answer. It is not a difficult question, and it is a linked answer type question. Take atmospheric pressure. Let me give you the missing data. 1.01325 bars. Okay, this is the atmospheric pressure, and other thing, yeah, this will be fine. CV, you know the value of CV, right? Do this question. Two minutes, and then I will be solving the question for you. Also, you have to consider air as an ideal gas. Consider air as an ideal gas. Okay. 2006. In the year 2006, this question was asked. This is a linked answer type question. The next question is also based on this data. Read the question carefully. Two minutes. Ravi Jha. Ravi Jha has said that the gauge pressure of air in the football at the stadium P is equal to 0.93. Let me check the answer. Yes. Yes. The gauge pressure is correct. Ravi, the gauge pressure is correct. Apurv Krishna, you have not given the correct answer. A is not the correct answer. Why? Apurv, please see in the question that gauge pressure is given. Gauge pressure is given. Ravi Jha. D is the answer. Correct, Ravi. Correct. D is the answer. One more minute and then I will be solving this question for you. Okay, let us solve the question here. A football was inflated to a gauge pressure of 1 bar. Now it is gauge pressure, okay, when the ambient temperature was 15 degrees Celsius. Now when the game started next day, the air temperature at the stadium was 5 degrees Celsius. Assume that the volume of the football remains constant at 2500 centimeter cube. This is in centimeter cube, okay. So when I will be solving the question, I try to solve the question in SI units, okay. So I will be changing this centimeter cube into meter cube, okay. The amount of heat lost by the air in the football and the gauge pressure, again gauge pressure. Those who gave A answer, they actually gave absolute pressure, okay. So you have been asked the gauge pressure of air in the football at the stadium respectively equal to. Please try to read the question very carefully what has been asked in the question, okay. Do not commit silly mistakes. You'll lose 2 marks and your rank will shift down by a huge number, okay. So first of all, we'll be finding the gauge pressure. It says that the volume of the football remains constant, okay. So as this air is an ideal gas, okay, so we can apply the ideal gas law, and volume is constant, so pressure is directly proportional to temperature. This I can apply, all right. So P2 by P1 is equal to T2 by T1, correct. But be careful here, the pressure is absolute, and in the question you have been given the gauge pressure, okay. So gauge pressure is 1 bar. The absolute pressure will be 1 bar plus this ATM pressure, atmospheric pressure, okay. Here also the absolute pressure. Is it fine? The temperature will be in Kelvin, okay. Now solve the question. What you have to do is you have to find the gauge pressure of air in the football at the stadium. That means the air temperature at the stadium was 5 degrees Celsius. So T2 is 5 degrees Celsius, or you have to put that in Kelvin. That means 288 Kelvin. So 288 Kelvin. T1, when the football was inflated, the ambient temperature was 15 degrees Celsius. That is, this is 278, sorry. T2 is 278. 5 degrees Celsius is 278. T1 is 288. P2 you have to find. P1 is what? P1 is 2.01325 bar, okay. So that implies you'll get P2 is equal to, let me check the answer, P2 will be 1.943 bar, 1.943 bar, okay, 1.943 bar. Yeah, Gursaran, 278 upon 288, yes. So now this is what, this is again absolute pressure that you have calculated, but you have been asked the gauge pressure, okay. So what you will do, you will subtract the atmospheric pressure from this value. So P2 gauge is equal to 1.943 minus 1.01325 bar, Okay, and the answer will be this 0.93 bar. Is it fine? Correct. So the answer is yes. The answer is 0.93 bar. This is the answer. Now what about this heat lost by the air? This heat lost by the air. Heat lost by the air is what? The volume remains constant. So Q is equal to delta U. Let's move on to the next slide. Volume is constant, so by applying first law, W becomes 0. Q is equal to delta U, and delta U is what? mCV delta T. Okay, you know the value of CV, that is 0.718 kilojoule per kilogram Kelvin into 10 to the power 3, that is joule per kilogram Kelvin. Okay, correct. What about this delta T? The difference is 10. Yeah, CV delta T. Correct. Okay, it will be mCV delta T. What you have written is that is joule per kilogram, but here the options are in joule. So you will have to find the mass, Gursharan. Okay, find the mass. How can you find the mass? The mass of the air in the football. How can you find that? Air is an ideal gas. So apply PV is equal to mRT. Okay, this is absolute pressure now. Please be careful. This is absolute pressure. Absolute pressure P1, which is 2.01325 into 10 to the power 5 Pascal. I try to work in SI units. What is volume? Volume is 2500 centimeter cube. That means 2500 into 10 raised to the power minus 6 meter cube is equal to m, okay, into 0.287. That is the characteristic gas constant for air into 10 raised to the power 3. This is R in what? Joule per kilogram Kelvin. Please take care of the units. And the initial temperature was, when it was inflated, the temperature was 15 degrees Celsius. That means it was 288 Kelvin. Okay. When you will solve this, yeah, when you will solve this, you will get the value of mass. Let me check the value of mass is 6.089. 6.089 into 10 to the power minus 3 kg. Okay, now what do you have to do? You have mass now, yeah. So put that here. Mass of air in the football. Okay, what you will get? You will get Q, that is 6.089 into 10 raised to the power minus 3. CV is 0.718 into 10 to the power 3 joule per kilogram Kelvin. Please try to work in SI units, okay? Because in the end, you will get the answer in SI units. And before filling the answer, just check in which units you have been asked to fill the answer. This is how you approach a numerical, okay? Into this is 10. So this answer will be this 43.72 joule. Okay, this will be in joules. Correct. Correct. 43.72 joule. So the answer is option D. Option D. Which temperature to take to find M? Gursharan, you have to take initial conditions. You have to take initial conditions. Take initial conditions. Because I have taken P1, T1, V1. However, V is constant. Okay. So take initial conditions. It has been said that the volume is constant. So this is constant. Okay. Okay. Let's move on to the next question. The next question for you. Based on the previous data. Now please read the question carefully. Gauge pressure of air to which the ball must have been originally inflated so that it would equal 1 bar gauge at the stadium. 1 bar gauge at the stadium. Okay. Please be careful. Is it fine? If we, Gursharan, if we take final conditions, you can take final conditions, no problem. You can take final conditions as well. Volume will be constant and mass will be the same. It's not an open system problem here. So, mass is not going out of your football. Okay. Give me the answer of this question. 1 minute. Solve this. Come on, 1 minute. You're welcome, Sanket. You're welcome. Just solve this question, yeah. Try to solve this question. Okay. Uh, what does this question say? It says that the data is same, yeah. The data is same. It was a linked answer type question. It says that the gauge pressure of air to which the ball must have been originally inflated. That means you have to find P1 gauge. I'm watching your all recorded lectures. They are very helpful. At Unacademy Plus, Sanket, 1.07. I get, sorry, I guess Ravi, you have given the, yes, correct answer. Ravi, you have given the correct answer. Good. So 1.07 bar is the correct answer. Okay. P1 gauge. Yeah. See, yeah. So gauge pressure of air to which the ball must have been originally inflated. That means you have to find P1 gauge. Please be careful. You have to find gauge pressure. Okay. So that it would equal to 1 bar gauge at the stadium. That means this is P2 gauge. Okay. Again, our air is an ideal gas. Volume is constant. P is directly proportional to T. Okay. But if you apply this P2 by P1 is equal to T2 by T1, please be careful. This is absolute pressure, absolute, and this is in Kelvin. Please be careful about this. Okay, so P2 gauge is 1 bar. That means P2 absolute will be 2.01325 bar, and the P1 that you will be getting, that will be absolute P1. Okay, so T2 is what? T2 was 5 degrees Celsius, is 5 degrees Celsius, yes, 278, and T1 is 288. So that implies you'll get P1. Let me give you the answer. You'll get 2.08 something, 2.08 something bar. Okay, this is absolute. This is absolute. Please. So P1 gauge will be what? You subtract the atmospheric pressure from this value and you will get the answer, that will be 1.07 bar. Okay. So what you have to do is, firstly, you have to read the question very carefully. Secondly, try to solve the questions in assignments. See the answer. No sir on YouTube. Okay, okay, Sanket. Thank you. Thank you for the appreciation. Yeah. Let's move on to the next question. The next question on your computer screens. Solve it. Very simple, easy peasy question. Direct formula based. Yeah, Ravi, subtract by 1.013 bar. Actually, the stream on YouTube actually lags by 20-25 seconds. Gursharan Singh, I am plus student. Is there any batch where you're teaching right now? Yes, I'm teaching on mission batches. Mission batches. And we have covered up to, steady flow analysis. Sorry, control volume analysis. That is, I have taught steady flow energy equation in the last class. You can watch my lectures, or you can watch my recorded lectures on Plus, and you can attend my class on Monday. The class is scheduled at 9:30 a.m. in the morning. Okay, so that will be a 3-hour class, 9:30 to 11, and then 11:30 to 1 p.m. Okay, but make sure you watch my previous lectures, because in the upcoming lectures we'll be solving numericals on steady flow energy equation. Mission batch, the name is Mission. You can get connected with me on Facebook. I will give you the links and all the important relevant information. Guys, give me the answer. Easy peasy question, 1 mark. Teja has given the answer as option A. Yes, option A. Option A is the answer. Others, please solve it, yaar. One more minute, and then I will be solving the question. Let me just have a sip of water. Teja has given the correct answer. Gursharan has given the correct answer. What are the other students doing, yaar? Give me the answer. Ravi has given me the correct answer. Okay. See, a cylinder contains 5 meter cube of an ideal gas at a pressure of 1 bar. This gas is compressed in a reversible isothermal process. Are isothermal process is given to you, yeah. Reversible isothermal process till its pressure increases to 5 bar. Correct. The work in kilojoule required for this process is very easy question. Work interaction in the case of isothermal process, you must be knowing the equation. Okay, and there are various forms of equation in this isothermal process, right? So let us see which equation to use. So work interaction in this isothermal process is equals to P1 V1 ln V2 by V1. Okay, mostly this is the equation that we use. But see, initial pressure is given, final pressure is given. So why do you use this equation? I can use P1 V1 ln P1 by P2. PV is equal to constant in an isothermal process, right? So P1 V1 is equals to P2 V2 and V2 by V1. That implies V2 by V1 is equal to P1 by P2. Okay. So what you do is now you put the values. So P1 is what? 1 bar, that is 1 into 10 to the power 5 Pascal. I will be solving everything. I will be trying to solve everything in SI units. Okay. So P1 is 10 to the power 5 Pascal, V1 is 5 meter cube, ln P1 by P2. P1 is 1 bar. Here I will not be changing this pressure value into SI units because this is a ratio. Okay. Because even if I write 10 to the power 5 and this will be 5 into 10 to the power 5, this will get cancelled out. Okay. But if you want to write it like this, you can do the question like this. Okay. So the value will be minus of 804.718. This will be in what? This will be in joule. I am directly writing the answer in kilojoule. Okay. What you do is you take 10 raised to the power 3 out of this value and you make it kilojoule. Okay. Now this is with a minus sign. Okay. But all the options have been given with a positive sign, so there is no confusion. Also, the work in kilojoule required for this process is all the options are in positive, so A is your answer. Okay. If in this line, instead of this line, this was written that the work in kilojoule required to be given to the system, then you have to put the answer with a you only have to take the magnitude in that case, because it is already given, because they have said that the work in kilojoule required to be given to the system. That means they already know that the work has to be done on the system. Okay, it's given. Then in that case you don't have to take the negative sign while filling the answer if this was an AT question. Okay, I hope you understood my point. 6 जून से आपकी क्लास स्टार्ट हुई थी सर? हाँ गुरशरण, मेरी क्लास स्टार्ट हुई थी. Okay, let's move on to the next question. Very easy. I guess this one will be the last easy. This one will be the easiest question. Work on system is happening, sir. Yes, the work on system is happening. That is why our answer is coming with a negative sign. Solve it. 30 seconds. 30 seconds. Not more than that. 30 seconds. Seconds. Come on, give me the answer. From the next question, we will be increasing the difficulty level. Okay, we'll be increasing the difficulty level from the next question, and also we'll be dealing with some conventional questions at the end of this lecture. Give me the answer. Teja has given the correct answer. Yes, very easy question, yeah. Very easy question. A pure substance at 8 megapascal and 400 degrees Celsius is having a specific internal energy of 2864 kilojoule per kilogram. See, specific internal energy, specific kilojoule per kilogram, and a specific volume of 0.03432 meter cube per kg. Its specific enthalpy in kilojoule per kilogram. Specific enthalpy in kilojoule per kilogram. Ravi, your answer is not correct. Specific enthalpy is what? H is equal to U plus PV. Okay. And I have already told you that whenever this specific word comes, we denote the properties by small alphabets, right? So you have to find the specific enthalpy. H is equal to, see, this is specific internal energy, that is 2864 kilojoule per kilogram into 10 to the power 3 joule per kilogram. Okay, plus the pressure is what? 8 megapascal. 8 megapascal. 8 into 10 raised to the power 6 pascal, that is Newton per meter square. Clearing your doubts on units as well. Okay, into V. What is this V? This is specific volume, that is 0.03432 meter cube per kg. Okay, so this meter square gets cancelled out with this with this meter cube, and only meter remains. Now this Newton meter is what? This is joule, yeah. So here the units are joule per kg, here the units are also joule per kg. You can add them. Okay, and you will be getting specific enthalpy in joule per kg. Okay, you have been asked to find the answer, to fill the answer in kilojoule per kilogram. Okay, so convert this here before filling the answer. Okay, your answer is 3156 kilojoule per kilogram. That means 3138.56 into 10 to the power 3 joule per kilogram. Is it fine? Is it fine? Correct? फील आ रहा है कुछ थोड़ा बहुत यूनिट्स का? अरे यूनिट्स पे गड़बड़ मत किया करो बिल्कुल भी. यूनिट्स पे गड़बड़ी नहीं करनी है. अगर वीक है, इफ योर यूनिट्स आर वीक, क्लास के बाद जाओ और कॉपी के पीछे राइट डाउन ऑल द यूनिट्स, राइट डाउन ऑल द कन्वर्जन्स. ओके, do not commit these silly mistakes, do not lose marks on these silly mistakes. Okay, next question on your computer screens. Solve this. Oh Ravi, I used entropy formula array. You have been asked specific enthalpy. See, this was a very easy question. Okay, that is why I always stress on, I always ask you again and again to read the question very carefully, very carefully. Solve this question. Come on. A well insulated rigid container, very important line. Insulated, well insulated rigid container. Okay, try to extract the keywords from the question. Try to extract the keywords from the question. Okay, do this question. 2015 GATE problem set 1. Give me the answer, guys. Come on यार, दे दो आंसर. सिस्टम ध्यान से डिफाइन करना. इसमें भी दो तरह से सिस्टम को डिफाइन किया जा सकता है. हाउएवर द आंसर विल रिमेन सेम. या इट्स ऑब्वियस ना, आंसर विल रिमेन सेम. एनीवन अभी तक किसी का रिप्लाई नहीं आया मुझे. हिंट, पहले क्या करो, इस पूरे रिजिड कंटेनर को, व्हाट यू डू इज you assume this whole rigid container as a system, as your system. Okay, anyone? 2 more minutes. Teja, correct. D is the correct answer. Let me check here. Yeah, D is the correct answer. Good one. Good one. Other guys also try to solve the question. What is pedal wheel work? Let me give you a hint. What is pedal wheel work? It is given by W is equal to T theta. Correct? I have taught you this in the class, in the previous lecture only. T is what? Torque. Theta is what? Angular displacement. Ravi Jha. Okay. D. Yes, yes. D is the correct answer. 1 more minute and then I will be solving the question for you. Do mark your attendance, guys. Please do mark your attendance. Like the session. That is your attendance. Sajal Kumar, yes, your answer is correct. It's D1285.4. Okay. See, in this question also, I will be taking this whole rigid container as the system, and then I will be taking the fluid inside this rigid container as a system. Okay. See what will be the change in the concept, that I will be telling you. Okay. So first of all, what I've done is I've taken this whole rigid container as my system, and what I do is I will be finding out the work, pedal wheel work, input pedal wheel work to my system. Okay, so that is what T is. Applied torque is 100 Newton meter. Okay, and a stirrer is rotated at constant RPM in the container for 1000 rotations. Okay, for 1000 rotations it is being rotated. In one rotation, you know, it covers an angle of what? 2 pi radian. So in 1000 rotations, theta will be 1000 into 2 pi. Okay, and the answer you will be getting in joules. Okay, let me tell you the value of this. This will be, oh, I've also written this in pi. So this is 200 pi kilojoule. Okay, this is what? This is the work, input pedal wheel work to the system. Is it fine? Now I'm again saying I have considered this whole rigid container as my system. Okay, so if I apply first law now, so Q is equal to delta U plus W. Okay, this is well insulated, it is given, so Q is 0. Okay, delta U is equal to minus W. That implies delta U is what? Delta U is what? M CV delta T is equal to minus of minus 200 pi kilojoule, that is into 10 to the power 3 joule. Is it fine? Why I have taken this minus sign? Because I have considered this rigid container, this whole container as my system. So the work is being done on the system. Is it fine? The work is, the pedal wheel work is being supplied to the system. Okay. So this becomes M is what? 1 kg. CV is given to you, that is 800 joule per kilogram Kelvin. Okay. That is why I have written the right hand side in joule. Okay. Into delta T. Delta T at a temperature. The initial temperature was 500 Kelvin. Let the final temperature be T2 minus 500 is equal to 200 pi into 10 to the power 3 joule. You solve this, you'll be getting the answer as T2 is equal to 1285. This is the answer. 1285.398. 1285.398 Kelvin. This will be the answer. D is the answer. Okay. Ravi, work on the system so negative. Yes, you're correct. One more thing. What I told you, that in this case, this is case 1, when I have considered this whole rigid container as my system. Okay. Now what I do is, I will be considering the fluid inside this container as my system. So what will change? Now the system has changed. Okay. Now this stirrer is no longer a part of my system. Only the air or the fluid. Yeah, it's not air, it's an ideal gas. Yeah. So the fluid inside my container is now the system. The stirrer is not a part of my system now. So what will happen? Let us see. See here. Now when I apply the first law on my system, the system is what? My ideal gas now. Okay. The pedal wheel work by the dissipation effect, that wheel work will be converted into heat, and that heat will now be supplied to my system, because my system is the ideal gas in the room, in the container. Is it fine? I have changed my system. I have taken the fluid in the container as my system. So that pedal wheel work by dissipation effect now will be converted into heat, and now this heat will be supplied to my fluid. Fine. And the value of heat will remain same, that is 200 pi kilojoule. That is 200 pi into 10 to the power 3 joule is equal to M is 1 kg, CV is 800, I guess it is 800. Let me check. Yes, 800 joule per kilogram Kelvin. Please be careful about the units. CV into delta T, that is T2 minus 500. Again you will get the right answer. Okay, the answer will be T2 is equal to 1285 point, what was the answer? 398 Kelvin. Is it fine? Is it fine? So option D is the answer. Is it fine? When you took the rigid container as a system, this is what we did. Correct? When you took the fluid inside the rigid container in the system, this is what we did. The answer will be same, but you try to learn the concept here. So that is what I was telling you in the first 2 classes, that how it is important to learn the concept of the system. Work is 0 cause of rigidity. Yes. No, work is 0. Yeah, what you did, Ravi Jha, work is, yeah, I forgot to mention this. Okay, this gas is not doing any work because of this rigid container. Correct? So when I take the fluid inside my container as the system, all the pedal wheel work will be converted into heat by dissipation effect, and this gas will not be doing any work on the container. It is a rigid container. Okay, so that is why this work will be 0 in this case. Is it fine? Let's move on to the next question. What you do is, this question is your assignment. Okay, this question is your assignment. Let's move on to the next question. This is your assignment. We'll be discussing this question in the next class. Okay, you can ping me on my Facebook profile for the PDF of this lecture. You solve this question. Okay, 10 marks. 10 marks question. Solve this question. Come on, solve the question. Please be careful about the units. Okay, please be careful about the units when you use the ideal gas equation. In the vessel A, the contents are in 0.5 kilomole, and in vessel B, the contents are in kilogram. Okay, the gas given is nitrogen, not the air. Please be careful. Gas is nitrogen. Please read the question carefully. I am giving you 5 minutes to solve the question. Try this. Solve the question. Hello Rehan. Please mark your attendance by liking the session and solve this question. Try to solve this question. You have 3 to 4 minutes. जाना नहीं है, क्वेश्चन सॉल्व करना है. Try this question, yaar. What you do is start from here. Find VA first of all. Find VA. How can you find the volume of the vessel A? Find this VA. Start by this hint. See, this is in kilomole. Solve the question here. Give me the answer of VA. How can you find the volume of vessel A? By ideal gas equation, yaar. Apply the ideal gas equation for vessel A. PV is equal to N R bar T. Why N? because the contents of vessel A are given in kilomole. Okay, so pressure in the vessel A is 1.5 megapascal, 1.5 into 10 to the power 6 pascal. Okay, Va that you have to find, N is 0.5 kilomole. What is R bar? R bar is universal gas constant, 8.314 kilojoule per kilomole Kelvin. Okay, but here let me change it here then, or what I will do is what I will do is let me convert it into joule per kilomole Kelvin. What is the temperature? 50 degrees Celsius, that is 323 Kelvin. Ravi, 894. 894 is what, yeah? 894 is what, yeah, Ravi? I guess you have committed some mistake. It will be if you are telling me the volume of this vessel A, it will be 0.895 meter cube. You have committed some careless mistake somewhere. Please take care of the units. This is kilomole. Let me write it here only. So kilomole and this kilomole gets cancelled out. Correct? This Kelvin and Kelvin gets cancelled out. So the right hand side is in joule. The left hand side is also in joule. Okay. In PV is equal to N R bar T. If we use this equation that is having N, that is number of moles. Okay. The R bar, the value of universal gas constant is 8.314 kilojoule per kilomole Kelvin. Okay, is it fine? Okay. Now what you do is find VB, that is volume of vessel B. Come on, go on. Find the volume of vessel B. Find the volume of vessel B. That is why I don't take much difficult questions here. You guys run away, yaar. When I was solving easy questions, when I was taking easy questions, there were a lot of students. There were 15, 16 students. When I took this question, students are 7. You have to solve this question, yeah. That is how your concepts will be developed. And this is not a difficult question. I mean, this is a medium level question. VB is 0.362. Yeah, you are correct. Ravi, you are correct. Now what you do is you find the total mass. You have the total volume now. Okay, VA plus VB will be the total volume. You find the total mass now. Okay, you find the total mass. See, this is nitrogen given. So molecular weight of nitrogen is 28. Try to find the total mass, and I will be calculating VB for the guys. So PVB is equals to MRTB. Okay, what is the pressure in this vessel B? 0.6 megapascal. So 0.6 into 10 to the power 6 pascal. VB is what we have to find. M is given now. M is given as 2.5 kg. So 2.5 kg. And what will be the value of R here? Now this R is characteristic gas constant. Characteristic gas constant is R bar by M. Okay, what is R bar? R bar is 8.314 kilojoule per kilomole Kelvin. Correct. What is molecular weight of nitrogen? It is 28 kilogram per kilomole. So this kilomole gets cancelled out, and that is how you get the units of R. That is kilojoule per kilogram Kelvin. Okay. So let me rub this R. Is it fine? So this is a 8.314 by 28, that is kilojoule per kilogram Kelvin. And what is the temperature in this vessel? This is 20 degrees Celsius. That means 293 Kelvin. Okay. Equilibrium temperature is given to you. It is given as 300 Kelvin. Okay. That is for you, Ravi. That data, that equilibrium temperature is for you. You solve the question. So VB comes out to be what? VB is 0.363 meter cube. Okay. Ravi, can you tell me the total mass? Mass in B is given. Vessel B is 2.5 kg. Okay. What will be the value of mass in the vessel A? Can you tell me the answer? Mass in vessel A. See, number of moles are given to you, that is 0.5 kilomole. And the number of moles is equal to mass of the gas upon molecular weight of the gas. Molecular weight of the gas is what? 28. Okay. So mass of the nitrogen in vessel A will be 0.5 into 28, that is 14 kg. So the total mass will be, add them, M total will be 16.5 kg. Is it fine? Why I need this total mass and total volume? Because it's given in the question that they are allowed to mix. The valve is opened and they are allowed to mix, and they achieve an equilibrium temperature of 300 Kelvin. Okay. So now the total volume is VA plus VB. The total mass is MA plus MB. Equilibrium temperature is given to you. What you have to do is you have to find equilibrium pressure by again applying the ideal gas equation. Okay, so that will be P equilibrium V total is equal to M total R T equilibrium. Okay, here R will be what? R will be again the characteristic gas constant. Okay, because I have taken M here. I hope these concepts are clear. If they are not clear, you can watch my previous videos. Okay, so equilibrium pressure is what you have to find. Total volume is 0.363 plus the volume we have, this is 0.895. So 0.895 plus 0.363 is 1.258. 1.258 meter cube is equal to mass is 16.5 kg. Yeah, 16.5 kg. Ravi. R is 8.314 into 10 to the power 3 upon 28. Okay, and this equilibrium temperature is 300. So all this you'll get the equilibrium pressure in Pascal. Okay, and you have to tell the answer in kilopascal. Yeah, you tell the answer in kilopascal. It's not mentioned here, but give the answer in kilopascal. The answer will be, let me tell you the final answer. It is 1168.6. 1168.6 kilopascal. 10 marks, conventional question. Fine. It's fine. 1155000. Teja Nani, your answer is approximately, I won't say it is correct. I think you have committed some, some small error. Please check your solution again. Okay. Please check your solution again. Okay. Let's move on to the next question. I hope this question is understood, right? I hope this question is understood, right? So let us move on to the next question, and let's do this one or this one. Okay, let's do this one. We have almost exceeded the time limit for this session. Do this question, one mark question. 1 minute. Give me the answer. Give me the answer. Come on. Ravi, Teja. C. Yes, Ravi, you're correct. C is the right answer. Easy question, 1 mark question. See here, cyclic process ABC is shown on a PV diagram. Okay, pressure is constant. Pressure is constant. Pressure is constant. Volume is increasing. Okay, that means V is directly proportional to T. Okay, that means this process on VT diagram will be represented. Ravi, sorry, D. No, it will not be D. C is the correct answer, yaar. C is the correct answer, Ravi. See now, this is pressure is constant, so V is directly proportional to T by our ideal gas equation. Okay, so V is directly proportional to T, and when you remove the proportionality sign, this will be a straight line. And V is increasing. See, V is increasing. This is V1, this is V2. Okay, V is increasing, and it will be a straight line. So C is the answer. Okay, just fine. B to C is an isochoric process. Isochoric process. So see here, B to C, constant volume, and PV is equal to constant means isothermal. Isothermal process. That means temperature should be constant. So C to A, temperature is constant. So C is the correct answer. Okay. Okay. So again, this question is for your. Yes, sir. Understand. Confused about PV curve. Yeah. So please don't get confused. Okay. Again, assignment question. Because our class is up to 7:15, and you'll be having another class after this. This is again an assignment problem for you, this one and the next one also. Try this question and this question as well. Assignment. I will be discussing these 3 questions in the next class. Okay, if you want the PDF of this lecture, send me a message on my Facebook profile. Search me and send me a message on my Facebook profile. Viresh Kumar is my Facebook profile. I mean, the Facebook profile is by this name. Please, you can follow me on Unacademy by the same name, and you can ping me there also. Okay, so let us move on to the subscription part. I'll be telling you some benefits of the subscription. Okay, we are having daily live classes in the mission batches, which we have launched. Mission batches. The English batch has been started from 1st May, and 1st June. On 1st June we started the batch in Hindi. It's a full-fledged batch, and all the topics, all the subjects for GATE and ESE will be covered. For GATE and ESE 2021 will be covered in detail, along with a lot of numericals. We'll be solving a lot of numericals. Okay, so I am already teaching basic thermodynamics on plus. In the last lecture, I have derived the SFE. SFE. If you want to feel the SFE, go to my lecture. Go to my latest lecture there on my profile. There will be a course by the name Basic Thermodynamics, and if you want to feel SFE, you watch lecture 1 of control volume analysis. Control volume analysis will feel SFE. Okay, and after that I'll be taking a lot of numericals on this SFE. Once we complete the syllabus by mid-November, we'll be launching the crash course, that is the revision course for you. So that is also included in this Unacademy Plus subscription. Okay. Also, we are starting with the this rank improvement batch on 15th June, in which about 2,500 to 3,000 questions will be dealt. 3,000 questions, man. A lot of questions will be dealt. Okay. Ravi and Kapil, thank you, sir. Thank you, sir. You're welcome, guys. You're welcome. You can, you can get connected with me on my Facebook profile or on my Unacademy profile. Then every fourth class is a doubt clearing session. Fourth class is a doubt clearing session that is actually very beneficial for you, so that every doubt of yours get answered in the class itself. Okay. We are also conducting weekly quizzes, so that you can judge your performance. Okay. We have launched the batches under this name, mission batch. Okay, mission batch. So every fourth class is a doubt clearing session. I've already told you this, and also I can start a live poll in the class, and that will give a leaderboard as well, so you can compare your performance among your batchmates. Next, how to buy the Unacademy subscription? You can go on the you can visit the Unacademy website, or you can go to the Unacademy app, click on GATE and ESE and click on get subscription. After that, these will be the plans that will be shown to you. It is beneficial to buy 1 year as well as 2 year plan. Why? See, the cost of 1 year plan is 25,000, and after my code, that is Viresh 10, you'll get 10% instant off. Okay, the price will be reduced to 22,500 for 12 months. See, and for 1 month the price is 5,000, and after my code this will be 4,500. So you see the comparison. This 1 year and 2 year programs are actually value for money. You can watch any faculty's lecture, and that too any number of times. Okay, and you can attend our live classes. You can ask the doubts. Generally the questions in the exams are asked from your doubts, and in the live classes, the benefit of the live classes is that you can ask your doubts in the class itself. Okay, please do not forget to apply my code, because you will be getting the 10% off instantly. Okay, the code is Viresh 10. Viresh 10. Okay, let's move on to the next slide. EMI option is there. EMI option is there on credit cards, and if you have an HDFC debit card, there is an EMI option on this debit card as well. Okay, you just have to apply Viresh 10, and also you can convert this amount in EMI if you have HDFC debit card. Okay, let's move on to the next part. Join the Facebook group, FB group. Hello Piyush, hello. Join our FB group for doubt solving. Okay, the group's name is GATE Aspirants MECCSE. GATE Aspirants MECCSE. You post your doubts here. We have specially hired interns for your doubts. You post your doubt here, and your doubt will be resolved as soon as possible. You can join our Telegram channel for daily quizzes, and the update on our classes, and for update on our classes, on our team's classes. Okay, this is how you can get connected with me. My Facebook profile, as I've told you, it's by the name Viresh Kumar. You search me on FB and you send me a message or you send me a friend request for any kind of doubt. Okay, any kind of doubt related to GATE preparation, ESE preparation, or career counseling, or any other emotional problem or any problem that you are having in your life. You ping me here, I am there for you. I'll be solving your query. Lots of students do ping me for this career counseling part, and I try to help them in the best possible way. Okay, so you can ping me on my Facebook profile, or you can follow me also on Unacademy, and you can ping me there also by the same name. So follow me on Unacademy for free special classes that I'm going to take on logical reasoning from 19th June. Okay, logical reasoning. Why logical reasoning? It will be covering SSC, JE. Sorry, it will be for NLC, Vizag Steel, and GATE and ESE exams. Okay, many of the engineering students face problem in APT and LR section. But believe me, guys, this is the most scoring session. Okay, if your FT and LR is strong, you can do wonders in the exam, yeah. So we'll be having these special classes on LR, logical reasoning. Okay, and maybe we'll be solving around 20 questions in each class, and I'll be taking 10 sessions of LR, free special classes. So we'll be solving around 200 questions of LR, and this will be beneficial for you. Okay, my coupon code is Viresh10 on Unacademy. If you want to buy Unacademy Plus subscription for any course, okay, this is my coupon code Viresh10. Okay, and if you want to follow me on Instagram, you can follow me by my username, that is Viresh_05. Okay, so this was the information I wanted to give, and this was all for this lecture. We'll be meeting on Tuesday with the next lecture. Okay, bye bye. Share this lecture, like this lecture, share this lecture with your friends, and let's meet on Tuesday. Okay, and if you have any doubt, just ping me on my profile, or ping me on my Facebook profile, or ping me on my Unacademy profile. Okay, see you on Tuesday.